Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve the questions on network solutions from IES examination. Friends, first let us solve question 1, which is very simple and straightforward. In this question, we are required to find P1 and I1. Observe the network. We find that 5 volt source is directly connected across 1 ohm resistance. Note that the current source of 1 ampere does not drive any current in the branch. Hence, P1 is equal to 5 volts and I1 is equal to 5 divided by 1 and hence I1 is equal to 5 ampere. So, option C is the correct answer. Very easy, isn't it? Friends, next we shall solve question 2. In this question, we are required to find the voltage across 2 ohm resistance. Observe the network. We find that 3 volt source is directly connected across 3 ohm resistance and hence we know that node voltage. Therefore, though the network contains 3 junction nodes, only one unknown node voltage has to be found out. This you have to understand. Therefore, let's assume the unknown node voltage as V1 as shown in figure. By writing the nodal equation for the node V1, we get minus 6 plus V1 by 1 plus V1 minus 3 divided by 2 is equal to 0. By solving this simple equation, we get the voltage across 2 ohm resistance equal to 2 volt. Hence, option C is the correct answer. Friends, next we shall solve question 3. In this question, we are required to find current through RL in the network shown in figure. Observe the network. The network has only 2 junction nodes. So, let's assume V1 as the unknown node voltage as shown. By writing the nodal equation for the node V1, we get V1 minus 420 divided by 120 plus V1 minus 420 divided by 60 plus V1 divided by 30 is equal to 0. By solving, we get V1 is equal to 180 volts. But I is equal to V1 divided by 30. By substituting the value, we get I is equal to 6 amperes. Hence, option D is the correct answer. Friends, next we shall solve question 4. The problem is very easy but tricky. It states that the VI relation of the network shown inside the black box has V is equal to 4I minus 9. Note that the current I is flowing into the black box. The terminal voltage shown is V volts. We are required to find the current I when 2 ohm resistance R is connected across the terminals as shown in figure. We find that a current of V by 2 amperes will be drawn by, say, the load resistance R is equal to 2 ohm. But we see that I is equal to minus V by 2, from which we get V is equal to minus 2I. From the given VI relation, we get V minus 4i plus 9 is equal to 0. By substituting for v and solving, we get I is equal to 1.5 amperes. Hence, option C is the correct answer. Is it tricky and easy? Friends, this problem is very easy, but we need to think a bit. Two circuits, circuit 1 and circuit 2 are given. We are required to identify the correct statement amongst the given statements. Observe the given circuit 1 and circuit 2 carefully. We find that two circuits are the circuits to verify the reciprocity theorem. You find that in circuit 2, the source and the response positions are interchanged. So, the first decision we make that the two ammeter readings will be same. So, out of the options A and C, the correct option is to be identified, for which we need to find the current through the ammeter. Consider circuit 1. Let V1 be the unknown node voltage assumed. By writing the nodal equation for node V1, we get V1 minus 10 divided by 10 plus V1 by 20 plus V1 by 20 is equal to 0. By solving, we get V1 is equal to 5 volts. So, current A1 is equal to V1 divided by 20. By solving, we get A1 is equal to 0.25 amperes. Hence, option A is the correct answer. I suggest you calculate A2. You should get A2 also to be equal to 0.25 amperes. Friends, we shall now solve question 6. It is given that 5 cells are connected in series in a row and 4 such rows are connected in parallel to feed the current to a load of 1.25 ohm. Each cell has an EMF of 1.5 volts with an internal resistance of 0.2 ohm. We are required to find the load current. The diagram of 5 cells connected in series is shown in figure. The equivalent voltage is 7.5 volts in series with an internal resistance of 1 ohm as shown. Further, it is given that such 4 rows are connected in parallel to feed a load of 1.25 ohm. The diagram drawn is shown in figure. We find that it is a two-junction node network. Let V1 be the junction node voltage. By writing the nodal equation, we get 4 times V1 minus 7.5 divided by 1 plus V1 divided by 1.25 is equal to 0. By solving, we get V1 is equal to 6.25 volts. But I is equal to V1 divided by 1.25. By substituting for V1 and solving, we get I is equal to 5 amperes. Hence, option C is the correct answer. Friends, finally, we shall solve this interesting question. It is given that the network N1 delivers power P to a resistance R. Further, if two similar networks are cascaded to deliver the power to the same resistance R, we are required to find the relation between the power consumed in the resistance R by circuit 1 and circuit 2. To solve this network. Let's use Thevenin's theorem. The Thevenin's equivalent of network N1 is shown in figure 3. From the Thevenin's equivalent circuit, we get I is equal to Vs divided by Rs plus R, from which we get P1 is equal to Vs squared divided by Rs plus R whole square into R watts. Now, let us consider the circuit N2 shown in figure 2. We find that both identical networks are cascaded to supply the same load of R ohm. So friends, now let us represent both circuits N1 and N2 using Thevenin's equivalent circuit as shown in figure 4. To make the solution simple, we shall convert the two voltage sources into equivalent current sources. The equivalent converted circuit is shown in figure 5. Now, we find that two current sources of Vs divided by Rs amperes are in parallel. Hence, they can be added and their equivalent is 2 Vs divided by Rs. Further, two source resistances of Rs ohm are in parallel. Hence, their equivalent is Rs by 2. Incorporating these results, let us draw the reduced circuit. Friends, the reduced equivalent circuit drawn is shown in figure 6. Using parallel branch theorem, I is equal to Rs divided by 2 and that divided by Rs divided by 2 plus R into 2 Vs divided by Rs. By solving, we get I is equal to 2 Vs divided by Rs plus 2R. Using this equation, we can find P2. We know P2 is equal to I squared into R watts. By substituting the values and solving, we get P2 is equal to 4 times Vs squared divided by Rs plus 2R whole square into R watts. Now, to find the relation between P2 and P1, let's find the ratio of P2 by P1. By substituting the values and solving, we get P2 by P1 is equal to 4 into bracket Rs plus R whole square divided by Rs plus 2R whole square. Now, you see that if R is very small, say nearly 0, then P2 is equal to 4 times P1. Similarly, if R is very large, say tends to infinity, then P2 is equal to P1. Note 4 times Rs plus R whole square divided by Rs plus 2R whole square is equal to infinity by infinity, and it can be taken as 1. Hope it is clear to you. Hence, option C is the correct answer. Interesting, isn't it? Friends, we have solved a few interesting questions in this tutorial. During the next tutorial, we shall meet to solve some more problems. Hope this presentation has kindled some of your thoughts. Thank you for watching.